Now, after learning about encoding, decoding, encryption, decryption, and hashing functions, now let's go with the final branch of cryptography, which is digital signatures. And we will also learn about digital certificates as well. These are two different things, so let's go with one by one. I'm starting with digital signatures. So it's somewhat similar to your hard signatures that you perform on the paper with a pen. It's somewhat similar to that. Whenever you sign a document, you simply create a trust that I have read all the documents and all the information that I have supplied in the form is correct, is it's not false. That's a simple signing means, right? In the same thing, whenever you sign a digital document, digital document. While signing a digital document, you create a hash out of the document, right? And that hash will be encrypted with RSA, and you will get an encrypted hash out of it, right? That encryption is performed with, let's say, some algorithm like RSA. It's not necessarily RSA, you can change it. It depends what algorithm you want to use. So you can change it. But RSA is a popular algorithm that is used. So I'm taking as RSA. Right. Now, this is a simple signing process, but you have to verify that the document you have signed is correct or not. It's being tempered, it's being modified or not. Right. If we want to verify it, not this one. When we verify the document, we again calculate a hash. Receiver will calculate a hash. So receiver will calculate a hash, and after calculating it, he will compare the hash with the hash decrypted from the document. Right? Receiver will calculate the hash and it will be compared with the hash that is present in the document. And because the hash is already encrypted, it needs to be decrypted. And for the decryption, receiver will use the public key. Right? Now the question arises, how the receiver gets your public key? Right? You have never shared the public key with the receiver yourself. So how the key is shared with the receiver? Right? Here comes the root certifying authority and the intermediate certifying authority. We call it root CA, certifying authority, which again gives authorities to intermediate CA, which again gives you the keys, which is, let's say in our case, I'm taking as myself. Right? So intermediate CA will give me 2 keys, will only give me 1, and the second one will automatically be shared by intermediate CA to rest of the intermediate CA and root CA. There are multiple of them. So I will only get the private key from the intermediate CA. Now it's his responsibility to share my public key with everyone else in the world. It's the intermediate CA's responsibility. Right? Now, if you want to understand it a little better, let's say I am the general user, and this general hierarchy is used to maintain a trust in the world, right? That I am the trusted user. If you know me, that you can know him as well, kind of thing. So to understand it better, let's give a simple example. First, let's say I am the user, I'm taking as myself. So let's say I have some money, I'll take it as a million, right? You can take it lower as well, it's again your call. So let's say I want to deposit this amount in a bank, right? And suppose I'm living in India right now. So in India, I want to deposit this amount in a bank, right? So what I'll do, let's say I'm new here, I'm not from India, and let's say I travel to some country like US, right? But I don't know the name of the banks on the USA, so I'll take the example from the India itself as well. So let's say I want to deposit this amount in an Indian bank, but I don't know which bank is more reliable, which bank will not collapse in future, which bank is more trustworthy, right? So to verify, to get the trust on a particular bank, let's say I will say I can trust on the government. Like government will never collapse, it will never get bankrupt, it will never cheat on me, right? That's something you can say. So government will never be uh, government is always trustworthy, you can say, right? So the highest level of trust you can take is the government, right? So we have the government on the top. Let's say I'm trusting on government here. That's my first level of trust, that I can only trust on government. If government says deposit in the first bank, I will deposit on the first one. If it says deposit on the 10th bank, I'll deposit on 10th bank. Simple case. I'm completely trusting on the government. Now government say I have a lot of work to do, I cannot handle your money. You can do one thing, you can go to one of my friend, which is RBI in our case, right? Okay, I'll say, all right, no issue. If you trust on RBI, then I can also trust on RBI. It's a simple thing. I went to RBI and again RBI says, hey buddy, I am again busy with some work. You can do one thing, go to one of my friend and give him the money, and that friend name is, let's say, SBI, right? So I'll go to SBI and SBI will take care of my funds in this case, right? So this is a simple trust chain which is maintained by the root CA, intermediate CA, and the certified authority equivalently. Like in this case, root CA is always trusted by the systems, by the application. For example, if I go to Firefox and let's say I have opened google.com, I have opened Amazon, I can go with the facebook.com as well, right? Now the question arises, how the browser knows that I am a trustworthy person, that the website I'm interacting with is the actual amazon.in or the amazon.com or the actual google.com, right? All the browsers first verify that you are actually communicating with the actual server, and then they will show up the web page. Otherwise they will not show you the web page, right? And they will simply reset the connection. To verify that trust, they always verify the certificate of the browser. So if you go with this lock here, you can go to connection secure, you can go to more information. The steps may vary based on the browser that you are using. Right now I'm using Firefox, so in the Firefox these are the steps. So in the security tab you can see we got the view certificate option, and here you can see we got 3 levels. First one is this GTS root R1, second one is WR2, and the third one is google.com. Now this is the same level of hierarchy. We got the root CA, intermediate CA, and the trusted party, right? Now if you go to settings here and check for certificates, you can see that this GTS root R1, if we just scroll a little bit more, now here it is. We can see this GTS root R1 is already trusted by the browser. Firefox says, if you are trusted by GTS R1, I can trust you. Or if you are trusted by any one of them, I can trust you, right? But if you are not trusted by any one of them, I will not trust you. That's a simple case, right? A friend of yours is friend of mine. Simple as that, right? And because the browser and the systems always carry these kind of certificates, they verify the trust. If you check here, you may get the GTS root C here as well, like GTS root R1, R2, R3, R4, right? Our systems, our browser, they always verify this trust based on the certificates that are available, right? That's how your main trust is validated. And that's the same case for your Android devices as well, including your iOS part, for all the operating system, not only for your Mac, Windows, for each and every operating system, they always verify the ownership with help of your certificate. So for the iOS, for the Android device, go to settings, go to security, you can go to encryption and credentials, and here you can go with the trusted credentials, and here you can see the same list, right? So these certificates, these root level certifying authorities are the major providers which share your public key to the verifier, to the customer who gonna verify your document, right? In this case, the receiver of the document will verify, will get your public key out of your certificates, right? So if we talk about the certificates, digital documents, digital signatures, and these are the same things. Now let's talk about digital certificates. So this is the general hierarchy which is followed by the digital certificates, right? And if we check the certificate here, we can see certificate has few common values, like who's the authorized party here, who issues the certificate, and when the certificate was issued, and till what time, what date the certificate is valid, right? And the public key is also present here, and the algorithm name is also listed here, right? Now, for each and every certificate, you will get multiple keys, you will get some hash values as well, right? You will get their issuer name, you will get their root certifying authority name, you will get their unique identifiers. So these are the few common things that are available for your certificates, in your certificates. Like in this case, we are using SHA-256 with RSA encryption, right? Because this is signed, this certificate is also signed, so they have encrypted the signature. First they calculate the signature of the document that they are using, right? They will create the hash with SHA-256, then they encrypt the hash with the RSA, right? So that's how it's generally performed. So if we go to the diagram here, so certificate has multiple options. First one is it share your public key. Second one, this is also used to provide trust that you are the actual owner. So ownership is also being verified with help of your certificates. For example, let's say whenever you upload a document, like if you have developed an application, let's say a simple example, like I have developed an application and I want to push it on a Play Store or App Store, right? And when I want to repush that same application for a newer version, let's say I pushed the version 1.0 a month back on, let's say in July month, right? And after a month, I want to push the newer version of the application with some new features and some bug fixes. The Play Store team will verify that you have signed your document with the previous certificate or not, previous key or not, right? If you have not signed the document with the previous key, you are not allowed to release updates for the application, right? So in most of the case, your ownership is verified with help of your digital certificates, right? And your public keys are mostly shared with help of your digital certificates. And in case of digital signatures, this is the general process. You take the data, you calculate the hash, and you encrypt the hash value, and you add it in the document and send it to the receiver. Receiver will again calculate the hash and compare it with the hash available in the document. That's how it usually works. That's all about the digital signature and certificates. Have a good day.